Hello, everybody. Now we'll talk about logos and how to interpret your multiple sequence alignment by using logos. Logos is very good way to represent your multiple sequence alignment, and simply you can get a good impact, high impact picture from your multiple sequence alignment using logo. The logo figure actually it represents your multiple sequence alignment, and you can notice that the conserved amino acid in your logo figure is stick out, indicating that region of potential biological importance. For example, here in that figure, you can see that at arrow number one, arrow number two, and number three and four, here you can see the cysteine stick out here, for example, and here and there, just to show that it's conserved among different species, which indicate that have a potential biological importance. So that's why we can use it very easily to indicate and to understand and to discover that importance places. Each position, as we said, is in the multiple sequence alignment can be indicated and as we can see that each position in correspond to a column in the multiple sequence alignment. So here in column number one, for example, which column number five, here this position, column number five, which is position number five at the same multiple sequence alignment, you can see here that there is letter S. Letter S here means that amino acid is conserved among different species at this position, which is position number five at the multiple sequence alignment. So I just show it here using arrow number one, just to indicate, to show you that that position is conserved by S, for example, as amino acid. The same thing apply here uh, at position 3. There is E, which means that amino acid conserved among different sequences at that position, which is position number 3. And of course, the same thing apply here at position 16, which is arrow number 2, or at that position, which is 31, at arrow number 3. So these just examples. Also, you can see that there is other position, like here 23, position 23. There is different letters here, N, Q, N, Q, and Q, and K, Q, K, N. So let's arrange it in that way, Q, K, and N. Why we try to arrange it in that way? Because usually the one at the top is the most frequent one. So here is Q, which more frequent than K and then N. But three of them exist at that position, which is position number 23 across all the compared species. So, and of course, you can see other positions that have the different letters, like here, for example, T, S, N, G. This four amino acids, D, S, N, G, exist in that position, which is position number 30 across different species. So you have four amino acid in that position, four different amino acid, of course, exist in that position. And as we said, you can arrange it from the top down to G, which this means that that position always contain one of these four amino acids in that position. And as you see here, I hope you can get it now. It's the low in each position, very conservative alignment column give you a high logo position. If there is high conservation in one position, the logo will be very high and bigger with a bigger one. Position contain a very heterogeneous mixture of symbols, yield low logo position, like the one here, as we said at arrow number 3. This is heterogeneous, so it's low logo position. The size also of each logo, as we said, depend on how frequently the letter in the column. So if you have three letters like here or even here, you can see that the K, for example, here in this position is much more frequent. That's why it's have a bigger and the size is much larger because this position have more frequent than the other letters. So this letter, which is K, is more frequent than G, for example. So that's why it's bigger. Here is K also much more frequent in that position, which is position number 21, than S and then others. So that's why it's bigger. So that's and also, as we said, the top letter is always most frequent. So the not just the size, but always the one at the top is the much more frequent. So if you would like to compare between sequences, that one like in any between if you talk about comparing DNA sequences or comparing between different protein sequences, the same thing apply, the same idea apply. So if I would like to see, for example, comparing between the exon-intron junction to see the most important nucleotides in that position, simply you can do that by comparing this with logos and take the sequences of that area and region that you would like to compare between them and use the logos just to uh, point out which residue are more frequent in that position than others. Here, for example, you will see different examples. Here, in this example, we try to find out which residue are much more frequent between in exon and intron junction. As you see, here GT is much more frequent, and here AG, for example, this is the beginning and the end. Also, you have also loop logo. This is the program we can use, of course. There's many examples. There's different examples. Here's a catabolite activator protein. This is a comparison between them. And here I describe which amino acid are more frequent and the position of each amino acid. Which one is much more conserved, like this here in that position, for example, or that position, and which one is heterogeneous, and the one that is heterogeneous, which one is much more frequent than other at the same position. Like here, if you look at position number 1, there's a different amino acid, which one are more frequent than the other at the same position. So you can see a different example, and these examples I used DNA and used also like here we can see the two recognition helix like so I use not just protein, I use DNA and protein, just try to give you an example that each one of them actually very important, and we can use the same technique for multiple sequence alignment using different proteins or using different DNA and try to compare between different sequences to get point out and to see which residue are stick out and represent that position much more frequent than the others. I hope you can practice in your own time and try to find which position are more frequent. And also don't forget to practice with our question and quizzes just to get more idea about this the using of this logo and I hope you will find it very useful for your paper and presentation. Thank you very much. See you in our next video.